Our goal with this video tutorial is to disseminate the knowledge necessary to perform wireless optogenetics experiments. By creating a low-cost and open-source solution, we hope to enable new discoveries in the field of neuroscience. So, let's get started, shall we? Oh, hey there, Yuji. What do you seem to be working on?
I'm assembling the cavities. So this is the cavity, 3 parts. This is bottom parts and middle parts, and this is top layer. So the mouse will come on top, and the rod will go stimulate there. So these parts are the phase shifter and power divider. This is the excitation source for the cavity. So these parts are all you can get it from off the shelf. And for the cavity, you can send the 3D CAD data to this link. Okay. So let's get started making the bottom parts. To make the cavity, the contact between the different layers is very important because there's a current leakage which makes cavities efficiency drops. So make sure you have to tighten the screw. To tighten up each several layers, you have to screw cross formation, something like this. Okay, so next let's put the excitation source. One more, because we need to generate circularly polarization. In order to make the circular polarization, we should control the cavity's frequency and also put the 90 degrees difference phase shift to the excitation. So how to do that is we use the phase shifters and they combine together to the one point. Okay, tighten up, and this is it.
So, the next component of our system is the power amplifier. To assemble the PA, you'll require 3 components. First, an AC to DC power adapter, a set of connectors, and 1 power amplifier. Information about where to purchase this can be found on our website, in addition to what power amplifier will be best suited to your application. We begin by cutting open the cord of the AC to DC power adapter. When you cut it open, you'll find 2 smaller cables inside. Typically, the colored cord will be your positive. After you solder your connectors to the wires coming out of the power adapter, make sure to wrap them in black electrical tape so as to cover any exposed metal. You can even wrap the whole assembly in electrical tape for safety's sake. Once you've prepared the power adapter, you can move to the power amplifier. On your PA, you'll find connections for power supply and for ground. Solder your other connector to those terminals and then cover those connections in black electrical tape as well. Once you've done both, connect the PA to your power adapter and you should be good to go. I'm going to hand this off to Kevin, and he'll walk you through the next portion.
Thanks. Now we'll generate the signal to send into the power amplifier. The signal generator system we have here is the Fabric, powered by Bio-X. There's a simple-to-use Windows interface where you can control the frequency and power of the signal generator. There's an equally easy-to-use LabVIEW brick to do the same thing in Max. Here, you can see I have set the frequency to 1.5 GHz and a power of 10 dBm. Next comes the optional step of confirming that the cavity is operating at the optimal frequency. To do this, I use this USB power sensor. Here you see the reading that's being picked up by the sensor. Optimally, we expect about 0.06 milliwatts. And you can see that as I tune the cavity, this number will increase. And I'll tighten it with a wrench just to make sure there's no leakage current. Now that we've completed the cavity, the power amplifier, and the signal generator, all that's left is an implant.
Okay, now let's make implants. So what we need is a tiny PCB board that's you lay out the implants. So what we need is diodes and capacitors and another type of capacitor. And we also have small tiny LEDs so that you cannot see, but I will show you later in the microscope. So this is almost done, and this is tiny wires. So it's better to have those kind of tiny tips and a soldering paste to do the implant, to make an implant. Okay, let's get started. First, let's cut the board. Just use the small scissors. It's pretty easy to cut the board because this material is made of Rogers 4350, and then it's only just 0.5 millimeter thickness. So it's already almost done. So after you cut, and you make sure it's small enough. Okay, let's cut this down to smaller, even more smaller, by using scissors and tweezers. Okay, now let's take a look at the under microscope. First, you paste the solder paste on top of the board, and then next, put the diodes. Make sure that diode's direction is correct. And after that, you put the capacitors on top of it, and also the coil. And attached together by solder. And after that, you put the twisted cable and then LED combined together, and then epoxy it. It's about 1 day to cure. So this is already dried. Wireless optogenetics implants. Okay, let's test how it works. The final products, let's try how it works.
Let's do it. On.
In the air, it doesn't work well, but holding by hand, imitating mouse, it works well. The pulsing will be controlled by the signal generator, and it still moves on but still turn on. Okay, so this is what we built a wireless optogenetics setup. So please enjoy making by yourself.
So here we've set the signal generator to 1500 gigahertz. Wait, no, that's too high. That's like 10G.
I've got a bright idea. Yuji, stimulate him again.
Okay.
Wait, did we need the blue LED or the yellow LED? Either way, proof the system works.